Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
My Weird Prompts is an AI-generated podcast produced by Daniel Rosehill, a verified human with documentation to prove it. While every effort is made to ensure our AI hosts draw from credible sources and run on cutting-edge models, they do occasionally make things up with alarming confidence. As with everything in life, and especially this podcast, treat all claims as spurious until confirmed to be not. Daniel, Herman and Corn accept no responsibility for any decisions made based on the confident ramblings of our artificial presenters. Now, today's episode.
Hello, Herman and Corn. So let's go back to talking about GPUs. So I've talked before about my struggles as an AMD GPU owner. I purchased a workstation for daily work about 2 years ago, and it was a tremendous computer. It was built as we order computers here in Israel with a really interesting purchasing process. I think that you define your requirements and they pretty much build your computer from components. So it's kind of a sort of a custom computer without the assembly. Anyway, this was before I started exploring local AI, and my only consideration, I guess, was, can the GPU run my displays? So it does. It's a AMD GPU Radeon 7700. But as I'm sure you both know, local AI and AI remains heavily biased towards NVIDIA. And while there's a lot of things that can run on AMD with ROCm, etc., I think I share the frustration of an awful lot of people with AMD that the impediments and the road bumps are just too bumpy at this point. So what I'm thinking about doing, this is kind of a medium-term plan for me for financial reasons. I'd have to save up for it, is I guess it makes more sense to me to have it doesn't make a lot of sense to me actually to have a GPU for AI, but I understand that that's pretty much the way things are at the moment. But the idea of actually using a TPU or an NPU makes more sense. But from what I understand, at the moment, these are primarily targeted for edge and embedded devices, and we don't yet, or servers or data centers, and we don't yet have, these aren't yet the drivers of AI inference at the workstation level. They're either too small or too big. So it's still a GPU question. So given that my thinking at the moment, and as I've already invested in a GPU for my displays, I use four screens. So it makes sense to me to keep my existing GPU just to drive my displays, and then to add in a second GPU. Now, here's what I'm wondering about from a hardware perspective. So let's say that I spec out an NVIDIA GPU that's going to cost, well, let's put the cost aside. But just to give, I guess, an idea of what kind of GPU I'm talking about, maybe $800 to $1,000, that category, maybe 12 gigabyte VRAM. That's probably what I'd be targeting to get an equivalent spec of my AMD. Now, if I add that into my computer as a second GPU, I presume that means that I'm going to have to think about two things: one, cooling, and two, power. And I don't have experience in fan cooling beyond what I've got so far, which is just kind of, I guess, the basic fans needed for single GPU cooling. I know there's water cooling and there's a whole bunch of different things. I don't want to have a computer that is really, really noisy. So before I even think about, doing a mixed NVIDIA AMD GPU rig on the Ubuntu workstation, is it going to be a lot of trouble to cool and to supply a power. Currently I have a 900 watt PSU, a power supply, and I'm wondering if that would be sufficient to meet the needs of the two GPUs running simultaneously, or if In addition to thinking about the fans and the cooling, I'd also need to plan for a fan upgrade. I guess I'm trying to spec at the moment if this is even a realistic idea, or if it actually would probably be maybe more sensible and cheaper just to rip out the AMD GPU and replace it with NVIDIA. And that process as well, obviously those drivers are not going to be compatible if I do that. How does one go about swapping out their GPU on a desktop? If I pull out the AMD and I want to swap over to NVIDIA, I presume I'm not going to be able to even boot into the graphical environment, and I might need to uninstall and reinstall the drivers. So how involved is that swap over process?
Welcome back to my weird prompts. I'm Corn, and I'm absolutely buzzing today because we're diving into a topic that hits close to home for anyone who's ever tried to get a computer to actually dock what they want it to do. As always, I'm here with the esteemed Herman.
Indeed, Corn. And this prompt from Daniel Rosehill is particularly relevant, touching on the ongoing hardware wars in the AI space. What many listeners might not realize is just how much the underlying silicon dictates what you can and can't achieve with local AI. It's not just about raw power, it's about ecosystem.
Well, I mean, hardware wars sounds a bit dramatic, doesn't it? I feel like maybe we're just talking about preferences, or perhaps historical market share. I wouldn't go straight to war.
Corn, you're looking at it too simplistically. When one ecosystem practically monopolizes a nascent, rapidly evolving field like local AI, it is a war for developers and users. The prompt specifically highlights the frustrations of an AMD GPU owner trying to navigate this NVIDIA-dominated landscape. This isn't a mere preference, it's a significant impediment to progress and accessibility for many.
Okay, you got a point about the impediment part. So, today's topic, stemming from our producer's own tech woes, is all about the challenges of running local AI on AMD GPUs and exploring the viable or not so viable options for those of us caught in the red team's camp when the AI world seems to be dressed in green.
Precisely. We're breaking down why the AMD experience for local AI often feels like swimming upstream, whether a multi-GPU setup is a feasible solution, the headache of swapping out an entire GPU, and even a quick look at alternative hardware like TPUs and NPUs, and why they might not be the panacea we hope for, at least not yet.
So, the core of the issue, as I understand it, is that if you've got an AMD GPU, like the Radeon 7700 that inspired this whole prompt, and you want to start dabbling in local AI models, running them right there on your machine, you're going to hit a wall. A big green wall, painted with NVIDIA logos.
That's a fair summary, Corn. While AMD has made strides with its ROCm platform, which is essentially their open-source software stack designed to compete with NVIDIA's CUDA, the reality on the ground is stark. Most cutting-edge AI research, development, and tooling are built with CUDA in mind. This means AMD users often face compatibility issues, slower performance, or simply a lack of support for popular AI frameworks and models.
But isn't open source supposed to be, better? More flexible? You'd think that would be an advantage for AMD, wouldn't you? The whole community pitching in?
In theory, yes. Open source offers immense benefits. However, in practice, the network effect of CUDA is overwhelmingly powerful. NVIDIA had a significant head start, investing years into building a robust ecosystem with extensive libraries, documentation, and developer support. ROCm is playing catch-up, and while it's improving, the maturity gap is still substantial. Developers often default to what works reliably and has the largest existing user base for troubleshooting and community support. It's not about the philosophical purity of open source, it's about practical deployment and iteration speed.
So, for someone like our prompt giver, who already has a solid AMD workstation for his daily tasks and displays, ripping it all out and starting fresh with an NVIDIA card isn't exactly a trivial undertaking. Especially when you're talking about multiple monitors, which he uses. He mentioned 4 screens. That's a lot to consider.
Indeed. And that brings us to the first proposed solution, retaining the existing AMD card for display output and adding a second dedicated NVIDIA GPU purely for AI inference. On the surface, it seems elegant. You leverage your existing setup for its strengths and introduce specialized hardware for its specific purpose.
I've seen people do that for gaming. Actually, one card for physics, another for rendering, back in the day. So it's not totally unprecedented. But what are the main hurdles with a 2 GPU setup, especially when they're from competing manufacturers?
The main hurdles are twofold: cooling and power delivery. Modern high-performance GPUs, particularly those suitable for AI tasks, are power-hungry beasts. A 900-watt power supply unit, which our prompt giver currently has, might be sufficient for a single high-end card and the rest of the system, but adding a second, equally demanding GPU, like an NVIDIA card in the 800 to 20,000 range with 12 GB of VRAM, would push it to its limits, if not beyond.
So you're saying the PSU might not have enough juice, and then even if it does, the heat output from 2 powerful GPUs crammed into one case could turn your workstation into a miniature space heater.
Precisely. And that leads to noise. Efficient cooling often means more aggressive fan curves, which translates directly into a louder system. For someone who uses their workstation for daily work and needs a relatively quiet environment, this is a significant quality of life consideration. Beyond air cooling, water cooling setups introduce another layer of complexity, cost, and maintenance that most users aren't prepared for.
I totally get the noise thing. My old laptop sounded like a jet engine warming up sometimes, and it was maddening. So, is there any way to manage that? Or is it just an inevitable trade-off if you go the dual GPU route?
It's largely an inevitable trade-off. While chassis design, fan choices, and careful cable management can help, fundamentally you're generating twice the heat. You can mitigate it, but eliminating it entirely while maintaining performance is a tall order. This is where dedicated AI workstations or cloud solutions often shine, as they can manage these thermal envelopes more effectively, but at a much higher cost or subscription fee.
It sounds like a lot of hassle just to run a few AI models locally. Wouldn't it be simpler, even if it means a bit more upfront work, to just replace the AMD card with an NVIDIA one entirely? Get rid of the AMD completely.
That is the other primary option considered in the prompt. While it simplifies the cooling and power dynamic by returning to a single GPU setup, it introduces a different set of challenges, primarily around driver management and operating system stability, especially on a Linux-based system like Ubuntu.
Let's take a quick break from our sponsors.
Are you tired of feeling like your brain is operating on dial-up while the rest of the world races by at fiber optic speeds? Introducing Neural Nudge, the revolutionary cognitive enhancer that promises to unleash your inner genius. Neural Nudge contains 100% pure, ethically sourced thought accelerators and focus fortifiers, harvested directly from the most vibrant dreams of certified quantum physicists. Forget coffee, forget meditation, just one sublingual neuronugget, and you'll be solving Rubik's Cubes blindfolded while simultaneously composing a symphony and learning Mandarin. Side effects may include occasional temporary teleportation, an uncanny ability to predict market trends, and a sudden inexplicable fondness for kale. Results not guaranteed, but neither is life, am I right? Neural Nudge. Because your brain deserves a turbo boost it probably doesn't need. BUY now.
Alright, thanks Larry. Neural Nudge, huh? Sounds like something I should probably not take if I want to stay grounded in reality. Anyway, back to swapping out GPUs. Herman, you were saying it's not as simple as just unplugging one and plugging in the other, right?
Not quite. On Windows, it can be a relatively straightforward process involving driver uninstallation and reinstallation. However, on Linux, especially with the complexities of GPU acceleration for various applications, removing an AMD card and introducing an NVIDIA one can be problematic. The existing AMD drivers could conflict, or the new NVIDIA drivers might not install cleanly over remnants of the old ones.
So, if I just pull out my AMD card, stick in the NVIDIA, and try to boot up, what's the worst that could happen? A black screen? A corrupted OS? Do I have to reinstall Ubuntu?
In the worst case scenario, yes, you might be looking at a non-bootable system or one that won't load the graphical environment, requiring a complete operating system reinstall. Even in less severe cases, you'd likely need to boot into a recovery mode or command line interface to meticulously purge the old AMD drivers and then install the NVIDIA ones. It's a process that demands a certain level of technical comfort and patience. It's not insurmountable, but it's far from plug and play.
That sounds like a weekend project at best. and potentially a very frustrating one if you hit snags. So it's a trade-off. Either deal with power, cooling, and noise for a dual GPU setup, or deal with potential OS instability and driver headaches for a full swap. There's no easy button, is there?
Not in this particular arena, no. The complexities of GPU drivers on Linux, combined with the divergent ecosystems of AMD and NVIDIA for AI, ensure there's always a challenge. This is precisely why the prompt giver is contemplating these options so thoroughly. It's not a trivial decision.
You mentioned TPUs and NPUs earlier as well. For the uninitiated, Herman, what exactly are those, and why might they be considered for AI, but then immediately ruled out for a workstation?
TPUs, or Tensor Processing Units, are specialized ASICs application. Specific integrated circuits developed by Google specifically for accelerating machine learning workloads, particularly neural networks. NPUs, or Neural Processing Units, are a broader category of processors designed for similar tasks, often integrated into modern CPUs or mobile chipsets. They excel at the highly parallelized matrix multiplications that are the bread and butter of AI.
Okay, so they're custom built for AI, which sounds ideal. Why aren't we all just using them instead of wrestling with GPUs?
Here's the rub. While they are incredibly efficient for AI, their current primary applications are either in massive data centers, like Google's own cloud infrastructure, or at the edge, meaning embedded devices, IoT, or mobile phones where low power consumption and real-time inference are critical. At the workstation level, for general-purpose local AI inference or training, they aren't widely available as discrete components in the same way GPUs are.
So, I can't just go out and buy a TPU for my desktop and plug it in like a graphics card? Because that would be cool.
You cannot, at least not easily or affordably, for a consumer-level workstation. They are either integrated into a system on a chip or offered as part of a larger cloud service. The drivers, software stack, and ecosystem for utilizing them at a standalone desktop level are simply not mature or accessible for the average user. They're either too small and embedded, or too massive and cloud-centric for a typical home lab or professional workstation. So for now, it's still a GPU question for most of us.
That's a bummer. So it really does boil down to NVIDIA, or fighting a constant uphill battle with AMD.
In the immediate term, for robust, broad local AI compatibility and performance, yes, NVIDIA remains the dominant and often less frustrating choice. AMD is trying, and ROCm is evolving, but the ecosystem gap is significant.
And we've got Jim on the line? Hey Jim, what's on your mind?
Yeah, this is Jim from Ohio. I've been listening to you two go on and on about all these fancy schmancy graphics cards and AI inference, and honestly, you're making it sound like splitting the atom just to run some computer program. My neighbor Gary does the same thing, overcomplicates everything. I swear, he spent 3 hours last week trying to fix a leaky faucet when a bit of plumber's tape would have done the trick. Anyway, you guys are missing the point. If your computer ain't doing what you want, you get a new one. Simple as that. All this messing with drivers and cooling and swapping out parts, why not just buy an NVIDIA machine if that's what you need for this AI stuff? Seems pretty straightforward to me. Also, the weather here is finally clearing up, which is a blessing after all that rain. But seriously, stop overthinking it.
Thanks for calling in, Jim. Always appreciate the straightforward perspective.
Jim raises a valid point about simplicity, but it oversimplifies the economic reality. Computers, especially powerful workstations, are significant investments. Just getting a new one isn't feasible for everyone, particularly when a perfectly good machine already exists. The goal here is optimization and maximizing existing assets, not necessarily a complete overhaul.
Yeah, and it's not like you can just return a computer you've had for 2 years because a new tech trend emerged. It's about making the most of what you have, and our prompt giver is trying to find the most cost-effective and least disruptive way to adapt his current setup.
Exactly. And the driver issue on Linux, for example, isn't about overthinking, it's about avoiding a broken system. If you just rip it out, you might end up with no working computer at all, which is far from simple. Jim's perspective is from a user who expects things to just work, and often, with specialized tasks like local AI, the user becomes as the IT technician.
So, Herman, what are some practical takeaways for someone in this situation? If I'm an AMD user, and I really want to get into local AI, what's my best bet?
From a practical standpoint, if you're committed to local AI and you primarily rely on open source frameworks, the cleanest path is to migrate to an NVIDIA-based system entirely. While the initial driver swap or even a fresh OS install might be a pain, it will save you considerable headaches in the long run regarding compatibility, performance, and community support.
But what if I just can't afford a whole new GPU right now? Or I really like my AMD card for everything else? Is there any hope for the dual GPU approach?
If the dual GPU approach is your only option, then you must meticulously plan for power and cooling. You'd need to assess your current power supply's headroom, potentially upgrade it, and invest in a case with excellent airflow. Furthermore, research specific AI models and frameworks to see if there's any nascent ROCm support, or if there are specific workarounds that don't require deep NVIDIA integration. But I would temper expectations significantly.
So you're saying if I try the dual GPU approach, I'm basically signing up for a science experiment?
You are essentially building a custom, somewhat experimental rig. It can work, but it requires more technical know-how and a higher tolerance for troubleshooting. For many, the path of least resistance, if budget allows, is to standardize on the hardware that has the most robust software ecosystem for their intended use.
This has been a really deep dive into the nitty-gritty of hardware and software ecosystems. It just goes to show that even in the world of AI, there are very human frustrations behind the scenes.
Indeed. The promise of AI is vast, but the infrastructure to support it locally still has its significant bottlenecks and biases. Understanding these underlying challenges is crucial for anyone looking to build or experiment in this space.
Absolutely. And it's a field that's evolving so fast, I wonder if a year from now, these conversations will be completely different. Maybe TPUs will be plug and play for everyone.
One can hope, Corn, one can hope. But for now, the GPU reigns supreme for workstation AI, with a clear preference for one particular vendor.
Fascinating stuff, Herman, as always. Thanks for breaking it all down for us. And a big thank you to Daniel for sending in such a thought-provoking prompt, straight from his own tech adventures.
My pleasure. It's always insightful to explore these real-world tech dilemmas.
And to all our listeners, you can find My Weird Prompts on Spotify and wherever else you get your podcasts. We love hearing from you, so keep those weird prompts coming. Until next time, I'm Corn.
And I'm Herman.
Stay curious. Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.